Welcome to another episode of Kovach Chemistry. Today's episode, Stoichiometry. But first, today's joke. What is a chemist's favorite plant? I bet you haven't guessed it, but it is a stoichiometry. So, what is stoichiometry? Well, it says it is the study of quantitative relationships between amounts of reactants, so we're talking about quantitative and amounts of reactants used in products formed by a chemical reaction. So we've got chemical reactions and we have numerical amounts. It's also based on the law of conservation of mass. And what does that say, everyone? Yes, that's correct. That matter can neither be created nor destroyed. Now, another way to think of that is to say that the mass of the reactants has to equal the mass of the, yes, I believe someone said it correctly, products. Good job. So now we need to look at the chart here. And we have a balanced equation is the first thing. Balanced equation. And here it is. And we have four substances in our balanced equation. And remember that these things on the left-hand side are called, that's correct, reactants. And on the right-hand side, these are called products. And so the first box that we're going to look at are representative particles. All right, so what kind of particles do we have in sodium? Well, sodium is an element, so I hope that you recognize that you have atoms here. Now, the other thing we want to recognize is that this number out in front tells us that we have two sodium atoms. All right, the next substance is H2O liquid, and I hope that you recognize that that should be molecules. And so here we have two molecules. All right, and the third substance is sodium hydroxide. It's got a metal and some nonmetals, so that makes it, yes, our favorite abbreviation, formula units. Right, and then finally we have H2 gas. Now you might say, well, that's an element. It is, but it's a diatomic element. And so for this one, we can say that we have one molecule because it has two atoms in it. So those are the particles that we see. All right, and then we want to take a look at, well, what does that mean in terms of moles? And so we will continue. So if we have moles, then what you'll see here is this is a unique relationship. The number of moles is given to us by the coefficient. So we have 2 moles of sodium, 2 moles of water, 2 moles of sodium hydroxide, and also 1 mole of H2, or hydrogen gas. So notice that the coefficients are giving us both the number of particles and the number of moles. And then we could look at, well, how does this translate into mass? So if we have mass, then we could use the atomic masses of the elements and just add them up like we have done previously. And so, for example, if you have 2 sodiums, you're going to have 2 times 23, which is 46. And then you're going to have plus 2 waters, so that'd be 2 times about 18 or so, which is 36. All right, and if we add these two together, of course, we get 82. Now let's see if that equals what we have on the right side. So 2 moles of sodium hydroxide, well, that's going to be 2 times, if you add sodium, oxygen, and hydrogen, you get 40, right? Plus, apparently I already added 2 here for the hydrogen, so that's going to be 80 plus 2, and lo and behold, that is 82. So why should these mass amounts be the same, everybody? Correct, due to the law of conservation of mass. All right, so the next thing is something called a mole ratio. It's a ratio between the numbers of moles of any 2 substances in a balanced equation. The mole ratio can be written for 2 reactants, or possibly 2 products, or even a reactant and a product, right? or maybe another reactant and another product. And all kinds of different combinations are possible, but 2 at a time is how they're written. So what we want to try now, as long as your equation is balanced, you can write those mole ratios. So we're going to write 12 mole ratios that can be written for the equation in number 2 above. Well, a 12 is a lot, so I'm going to start you off and then see what you can do to finish up. All right, so let me give myself some more space. And the first relationship I might write is between the sodium and the water. So we write it like that. Now remember that a ratio can be written as a fraction, and that's usually the most helpful way you're going to do it when we're doing stoichiometry in chemistry. Now another thing that is true for fractions is that you can write reciprocals. You can do the same thing in chemistry. So a second molar ratio here might be 2 moles of water over 2 moles of sodium. Now notice that you might say, but Mrs. Kovacs, we could divide the 2's out. Yes, we could. I would recommend, though, that you leave those 2's in there so that you know that you've taken care of the coefficients. Because if you don't include the coefficients from your balanced equation, your problem's not going to be right. So leave those coefficients in there, and you should have fewer errors that way. All right, see if you can write some more of the mole ratios, and we will go over those in class. All right, what are the tools or items that you might need for calculations involving stoichiometry? Now, take a minute and think about what your answers would be to this question, and I will write down a couple here, and then maybe we'll discuss more in class. So stop the video and write down your answers, and then check back with me. All right, so what are some things you came up with? Well, if you're going to do calculations, you probably need a calculator. Very good. Now, if we are dealing with elements and compounds, you probably also need that all-important periodic table. So there's 2 things to get you started. And you can, of course, come up with some more, I'm hoping. One of the things that you definitely need is a balanced chemical equation. So that might be the most important thing on your list. But we'll talk about what else you came up with in class. All right, next we have a mole map. And it should look familiar to you. It's very similar to the one that we did earlier in class. It says, how is the map shown above similar to the mole map that we studied in the last chapter? I don't think it was chapter 11. I think it was chapter 10, but that's okay. But anyway, so how is this similar to the map we had previously looked at? Well, you can see that both maps contain mass in grams, moles, and representative particles, right? Our earlier map. The earlier map we looked at would have been maybe just 1/2 of this map. And so this map is different because it has 2 maps combined. And what connects these maps? Well, it's connected by something referred to as the molar ratio, which we just did. It's still going to be multiply out and divide in. Okay, multiply out, divide in, multiply out, divide in. And so you might want to jot that down on your paper if you don't remember that. All right, so anyway, we'll discuss this a little bit more in class as well. General steps in problem solving. The first thing you want to do is balance that equation, or make sure that it's balanced. Then you want to make sure that each substance's formula is written correctly before you attempt to balance it. So that, I guess you should reverse these. Do this first. Make sure your formulas are written correctly, then balance your equation, then figure out what you're given, what you're supposed to find, then look at your map, figure out where you need to start and stop, and then write down your given quantity and set up the problem. Remember that the mole ratio step is required in every stoichiometry problem, so you don't want to miss those. All right, and so we're going to, or rather I'm going to work on some of these problems for you, and we will do the rest in class. And so let's see, but I want you to try them on your own as part of your homework. So let's go ahead and do problem number 1 here, or rather problem number 9. All right, problem number 9. Now, the first thing we want to note is what is the equation? And so here is the equation written from your book. It's 2SO2 plus O2 plus 2H2O yields 2H2SO4. So we have our balanced equation. And you would assume that if they've given it to you in the book, it's balanced. But you could always check to make sure. So the next thing we know is that we have 12.5 moles of SO2. So we have 12.5 moles of this substance. And we are supposed to find the moles of H2SO4 that would be produced. And then as a second problem, we are supposed to find the moles of O2. So these are two separate problems. So let's take the first one. We would start with what we have, and now we want to go back and look at our map to see where I'm starting and stopping. Well, for both of these problems, we want to move from moles of A over to moles of B. So notice that how we get there is by using the molar ratio. And this is the step that we did earlier where we want to look at a fraction that relates one substance to the other. And there's the bell. All right, so next we would say we have 12.5 moles of SO2, and we need to figure out what molar ratio I would need to use in order to solve for moles of H2SO4. So moles of SO2 would be in the bottom in order to get those to cancel. Moles of H2SO4 would be in the top, and then all you have to do now is add in the coefficients from the balanced equation. And you might say, well, but those would cancel. They would, that's true. But remember to always write those in there so that you know that you've taken into account those coefficients. So because these actually do cancel, and of course you can also see that moles of SO2 cancels, then what we have left would be 12.5 moles of H2SO4. All right, so the second problem on number 9 here would be to take the 12.5 moles of SO2 and convert that to O2. So you take the same steps that you did in the first problem. You're still going to have 2 moles of SO2 on the bottom because you still want to get that to cancel. But now you're going to switch and go to moles of O2, and the coefficient for the oxygen is 1. So now you're going to have 12.5 divided by 2, which is going to be 6.25 moles of O2 is the correct answer to this part of the problem. All right, I'm going to skip on down to problem 12 in this set and see if you can work 10 and 11 on your own. But number 12, the equation that we're working with is 2NaCl solid yields 2Na solid plus Cl2 gas. And we are to find how many grams of chlorine would be produced if we started with 2.5 moles of sodium chloride. So take a look at your map, which I am not going to show you here, but take a look at your map and you'll see that you're going to start with moles of A and you're going to end with mass of B. So you've got to go from substance A, which is the sodium chloride, over to substance B, which is the chlorine. All right, so we need to look at our map now and figure out the steps that we want to take. So we're going to start with 2.5 moles of sodium chloride, and we want to convert the moles of sodium chloride over to moles of chlorine. So the first step would be to use that molar ratio. So we're going to say that moles of sodium chloride is converted to moles of chlorine gas. Now let me just take a moment to stop here and say, remember, or one thing you might want to do is just put the units in first and then add your numbers later. You want to make sure that what you're starting with is canceling here, and what you want to end up with is in the top here. All right, so now we want to add in our coefficients. So I checked the sodium chloride, and that coefficient is a 2. The chlorine coefficient is a 1. All right, so now I'm half done with the problem. Now you could at this point do it in 2 steps. You could go ahead and say 2.5 divided by 2 is 1.25 and then continue on. So if you want to do these problems in 2 steps or in 1 step, it really doesn't matter. You should get the right answer either way. Typically, I'm going to do them all at once like I'm doing here. So now that I have moles of chlorine and I want to get to grams of chlorine, I would look to see, oh, okay, I'm going to go out to mass. So that means I'm going to multiply out, and I'm going to calculate the molar mass of Cl2. And if I do that, I should get 71 grams, or approximately 71 grams. And so now I can check and see, well, what cancels here? Moles of sodium chloride, moles of sodium chloride, moles of chlorine, and here we are left with grams of chlorine. And so if I do the multiplying and dividing, remember that you have a couple of options here with your calculator. You can take 2.5 times 71 and then divide it by 2, or you can take 2.5 divided by 2 and then multiply it by 71, right? However you want to do it, but you should come up with the correct answer of, lost my place, there we go, 88.8 grams of chlorine. So there you go. So see what you can do with problems 13 and 14 and also 10 and 11. All right, thank you for watching.